Hi everyone. Today we are going to talk about algebra functions, function composition, and decomposition. In this video, we are going to focus on algebra of functions. Given two functions f and g, we can do the following to the two functions. We can add them, subtract them, multiply them, and divide them. Let's get familiar with the notation. You have f plus g of x. That can be interpreted to f of x plus g of x. And then f minus g of x is the same as f of x minus g of x. F times g of x is f of x times g of x. And then finally, f divided by g of x is the same as f of x divided by g of x, with the condition that g of x is different from 0 because g of x is the denominator. Let's look at this example. We have m of x is equal to 4x, n of x is equal to absolute value of x minus 3, and p of x is equal to 1 over x plus 1. Determine m plus n of x. First, let's translate it to m of x plus n of x. Now we just substitute the functions. So m of x is defined by 4x, and n of x is absolute value of x minus 3. Since these two can't be simplified, one x is inside of the absolute value, the other is on the outside. We cannot combine them. So this is the answer. Let's look at the second example. This time, instead of x, we actually have a value that we can evaluate. So let's first translate it to m of negative 2 minus n of negative 2. So function m is defined by 4x. With x being negative 2, we can substitute negative 2 in for x in the m function. And then minus n of negative 2. N is defined by absolute value of x minus 3, but x is now negative 2. So we substitute negative 2 for x, and we have this. Simplify further. 4 times negative 2 is negative 8. And within the parentheses, we should get negative 5. Within the absolute value, we get negative 5. And absolute value of negative 5 should give you 5. So we're looking at negative 8 minus 5, which gives us negative 13. Now let's try multiplication. M times P of 1. So M is determined by 4x, but let's first rewrite it in the form M of 1 times P of 1. M is 4x, so we're looking at 4 times 1. And then times P is 1 over x plus 1, so we're looking at 1 over 1 plus 1. This will give us 4, and the other quantity is 1/2. 4 times 1/2 gives us 2. Finally, let's do this division. So translate this to m of x divided by n of x. M of x is defined by 4x, and n of x is defined by x minus 3, absolute value. Since we can't simplify that any further, we're going to keep the function that way. Note that the domains of all these operations, f plus g, f minus g, f times g, f divided by g, are the intersection of the domains of each function, f and g. Except for f over g, we need an additional condition, which is g of x has to be different from 0, because g is in the denominator. So whichever function is in the denominator, we need to add the condition that that function cannot be 0. So let's find the domain of n over m of x. So first, let's translate it to n of x over m of x. Now we are going to find the domains for each function. So n of x is defined by absolute value of x minus 3. Now, when I look at this function, I don't see any square root. I don't see any fraction. In fact, there's no restriction for x in the absolute value function. X can be anything, negative, 0, positive. So therefore, the domain for this is negative infinity to positive infinity. Function m of x is defined by 4 times x. Same with this function, there's no restriction, so the domain is all real numbers. In addition to these two domains, we also need to make sure that the denominator m of x cannot be 0. So m of x cannot be 0, which means that 4x cannot be 0, and therefore x cannot be 0. So at the end, when you combine all these three domains, one is all real numbers, second one is all real numbers, and the third one is x cannot be 0. Then we get x cannot be 0 as the intersection. So to write the domain using interval notation, we write negative infinity to 0, not including 0, and then union with 0 to infinity, again not including 0. So this right here is the domain for n over m of x. Let's find the domain of m times p of x. First, let's translate to m of x times p of x. M of x is 4x, and p of x is defined by 1 over x plus 1. These can be multiplied together and give us 4x over x plus 1. Now, to find the domain, you will first find the domain of m of x, which we found earlier, and that is negative infinity to infinity. Now, domain of p of x. P of x is the function 1 over x plus 1. Now, this is a rational function that has a denominator, so it has a restriction, that is x plus 1 cannot be 0. X plus 1 cannot be 0 means x cannot be negative 1. So therefore, the domain for p of x is negative infinity to negative 1, union with negative 1 to infinity. Finding the intersection of these two domains, we should get the domain of the product of the two functions should be negative infinity to negative 1, union with negative 1 to infinity.